let's just short these out, see what happens. Alright, so today's video will cover a topic that I've actually been asked about a couple of times ever since I built my 12-volt lithium ion battery pack. And I've been asked how I charge this thing before, and I actually have done an entire video about that where I take this thing and I just hook it up to a hobby RC charger, which is what I use for this thing. It's just a 3S balance charger. One thing that I don't like about that method is it is pretty slow. It can only put out about 3.3 amps, and it also cuts off every 90 minutes as a safety feature, which this thing is somewhere near 18 amp hours, so it's kind of a pain to charge it with that. So I would actually kind of like to be able to use something different. And a lot of people have been asked how to do it with a BMS, and a lot of people don't want to use those hobby grade chargers, which is understandable enough, though if you get a decent one of those hobby grade chargers, it will charge faster, though it's not as convenient because you have to have that charger in order to charge it. With something like a BMS board, you could essentially just carry around a generic sort of power supply and plug it straight into this. Now I have actually gotten two of these, and I've done a little bit of testing with both of them, and so far I have been highly disappointed. And let me explain why here. Now, the first one, I just went on Amazon and I looked up 3S BMS, so 3 cells in series and battery management system. This is the first thing that comes up. It costs $10.90. It is rated for 30 amps. And as I didn't realize it in the title at the time, this isn't actually what I would consider a BMS. This is just a protection board. It doesn't actually claim to be a BMS. It is claimed as a protection board. And we'll do some tests on this and see how well it works for that as well. And I looked up the chip on here. It is actually a dedicated 3S or 4S. It depends on which chip version you buy. But it's a dedicated protection chip just for 3S and 4S packs, and you can buy different ones that have different voltage cutoffs and whatnot. So it monitors every single individual cell, and it will tell you which, or it will cut off if one's going too high or too low. Now this one cost $5.90. It's rated at 20 amps, and it actually has, if you look down here, these things are actually DWL1 chips. So those are single cell protection. And this one is advertised as a BMS, though it is what I would classify as a protection board again, because it does not do balance charging. Well, really it doesn't do charging properly at all, because the way you're supposed to do lithium charging is constant current, constant voltage. Though you could achieve that with an external power supply. Some kind of current limiting power supply would be able to actually do that properly. Though these things, it's just a binary on-off switch, and that's what the, there's a bank of MOSFETs right there. And these have, you know, the current sense resistor on them and things like that as well. So I've done some testing with these. I'm going to go ahead and do some more testing with them, and we'll see what we get. So this one, the wiring is actually pretty simple on it. So it actually says 12.6 volts, 8.4 volts, 4.2 volts, and 0 volts, which is where I have just attached a balance connector. And for testing this, I have a small 3S battery pack, which is in pretty sad shape, really, but it'll be good enough for this. And this, of course, has a balance connector on it, so I can just plug it straight in. And then up here we have the plus and minus, which would be the charge input and the current output. And attached to that, I have a capacitor and a bridge rectifier, and then this is a 12.6 volt transformer, and I will actually put a resistor in series with this in order to limit the current, because this battery pack doesn't really like to be charged in anything more than about an amp. And then that's just wired into the wall. So this is capable of pushing about 18.4 volts DC, and we're just kind of trusting that this thing will cut off before it gets way too high. So I'll go ahead and I'll get a resistor in series with that. We're not going to use too much of a resistor. I have probably some kind of piece of nichrome or something like that that I could use, but or I could use this resistor right here. This is a big old 10 ohm resistor. I'll probably just grab some alligator clip wires and use a couple of coils of that because I don't need the entire 10 ohms. Because it will take some current, just not a whole lot. So we're just going to hook this up. I think we're going to go from this point to roughly here. It's probably going to be good enough. And we're going to hook this across the bridge rectifier and the 12.6 volt AC output of the transformer. And that's just going to limit the current a little bit because it will push like 4 or 5 amps if we're not careful with it. And then I'm going to plug that in and we'll do some measurements on it just to show what we've got. So before hooking it up to the battery, if we measure the voltage across the bridge rectifier, about 18.67 volts, which should be plenty to fry a lithium battery pack, assuming something goes wrong. And we have the battery pack voltage is 12.37, so mostly full. And if we measure some individual cell voltages here, we have 4.08, 4.15, and 4.13. So there is one that's a bit low and one that's a little bit higher than the rest of them, so we'll be watching those to make sure it actually cuts off. So now what I'm going to do is go ahead and plug this in. Should start charging in theory. And we can check that if we set our meter over here to DC amps, should be less than 2. Zero that out, maybe. Put the wire in the clamp and we're pushing 0 amps through it. Turn the power on and off again, see what happens. Maybe making a bad connection somewhere. It may just not like it because it had 18 volts to start with. We'll hook the battery up first. That should probably help it because it was probably measuring that all the cells were at 0 volts. So might have confused it slightly. And now the output is probably not going to be live. Yeah, it is live. This one actually says on the Amazon listing that you have to apply power to this thing in the form of charging the batteries before it will activate. So that may or may not be completely true. Who knows? Let's just hook this up now. Voltage shouldn't shoot up by too much, especially if you don't touch the probes on it. So yeah, we got about 12.6 already volts DC there. Let's see how much current we're pushing into the battery. About 0.8 amps, which should be fine. And let's measure the battery voltages again. Since it already shot up to about 12.6, I'm kind of curious. Oops, that's the AC. 12.5 across the pack. First cell is 4.13, the one that was really high before. 4.2 already. And the last one, 4.17. So I'm just going to leave this for a little while, and I'll continue to watch the voltage across this thing and all the individual cells, and I'll get back to you when and if something exciting happens. Alright, so it's been a little while. We'll go ahead and check our voltages again. The entire pack voltage is currently at 12.73, which is 0.13 volts over what it should be. First cell is 4.2, which is fine. Second cell is not making a good connection. 4.28, which is over. And the last cell, 4.24, also over. And I'm pretty sure that we are still pumping current into this. So let's go and look. DC current. Yep, 741 milliamps are still flowing into the battery. So I'm probably going to go get a meter that has a min-max function and put it across this and see how high it actually gets. Alright, so sadly in that few minutes that it took me to get the multimeter out and actually hook it up, it did actually cut off. So we're now sitting at 12.61 volts until the clip fell off. But anyway, it did get up there a little bit high. And one of my suspicions with this particular BMS board is that it seems as though it has to get all three of the cells in a fault condition, i.e. the voltage is too high or too low on all of the cells, not just one of them, in order to get it to trigger. So we'll go ahead and measure our voltage across the individual cells again and see where we're at. And if we measure the voltage across this point, it should be back up to that 18 volts or whatever. Yeah, 18.5. This one's at 4.16, so that one actually did, it was at 4.2 though when it was charging. That one, 4.24, so that one's high, definitely. And this one is 4.21, which is a little bit high, but not groundbreakingly high. Okay, so that pretty much does it for the charge test. Now we're going to move on. I'm going to disconnect this, and we're going to put a load. I'm going to desolder this, and I'm going to put a load on the other side of this board, and we'll see what the voltage goes down to. Okay, so on to discharge testing. This is also going to test another thing. As I mentioned earlier, the Amazon listing says that you have to activate this by charging it first. We'll see if that's actually true or not. So I've brought back our old friend, the big old 10 ohm wire wound resistor. I've put the clip on about halfway, should be about 5 ohms, so we're going to dissipate about 2 amps. So a decent bit of heat will come out of that resistor. And I've got the clamp meter set up over here. We're going to go ahead and plug that in and see if it just turns on, or if I'm going to have to do some kind of activation to get it to turn on. And it does appear as though we are going to have to do some type of activation, because that is not pushing out any current. And we can switch this over to voltage and see if there's anything coming out of here. It could just be a bad connection, but no, it doesn't look like there's anything there. So we're going to have to bring back our old friend, the transformer, and just give it a little shot of current, I presume, in order to get it to turn on. It should be in this direction. Now if we measure the voltage across here, we should hopefully have something. Yep, 11.9 volts, so we are indeed drawing probably a decent bit of current from it. Over 2 amps. Yeah, we're drawing about 3 amps there, so we're going to go ahead and let that drain. Shouldn't take too long to drain that down below the reasonable voltage for this. But anyhow, hopefully those little connectors and wires will actually handle that. I think it'll be okay. Of course, that resistor is going to get awful hot, but I think it should be able to handle that. It's just a bunch of nichrome wire and a piece of ceramics. So anyway, I'll come back to you when something interesting happens. Alright, so here we have our minimum voltage. That's the max that it's been so far. The minimum voltage was 9.27. And I do believe the reason why it was 9.27, if we measure across the individual cells, we had one cell dip below 3 volts, which was that one there. It's currently at 3.12 as it starts to recover. Though the other 2 sets of cells, that one's at 3.5, and this one is at 3.53. So it does most certainly appear to be monitoring individual cells and catering to their needs, though the high voltage cutoff just seems like it's a little bit too high for this, if you ask me. But overall it does work. We haven't tested short circuit current. We could do that, make sure we have good current protection. Let's go ahead and do that. Actually, I'm going to have to reactivate it because now that it's died, we have to reintroduce some voltage into it. So we're just going to tap this across the inputs / output, and that should re-energize those clips. And we're going to set this back to the live voltage. That's the average voltage. This is the live voltage. And if I put a load on this, it should dip a little bit. Make sure it's on. Yep. That may have actually just disabled the output again. Nope, doesn't seem like it did. Let's just short these out, see what happens. .27 volts. It looks like it auto recovers from that. You see the spark when I hook them up. So yeah, overcurrent protection seems to work on this. So that's good. So anyhow, that is some basic testing of the first BMS board. We'll have to do some other testing on the other board that I have as well. So, alright, so that serves some basic testing on this first cheaper BMS board. So this is the 20 amp one, costs $5.90. I'll put the link in the description. We're gonna have to test the other one out as well, so I'll go ahead and get onto that. Alright, so we are going to bring in the same test setup essentially for the red 30 amp one. Mind you, this one costs a little bit more money. It's got a dedicated chip just for this. The other one, it seems like they've kind of jerry-rigged in the DW01s in order to work, and it does work. It seems to be monitoring the individual cells, though the high voltage cutoff seems to be a little bit too high, at least for my comfort levels. Low voltage cutoff doesn't seem to be too bad. It was just a little bit under the 3 volt mark when I was measuring the open circuit voltage, so low voltage cutout might be a bit low as well. Neither one of these do any kind of balancing, which is kind of unfortunate because that's what I was really hoping for when I started looking at BMSs, because that's kind of something that you need, well, at least in my opinion, you need to be able to balance charge these lithium cells. At least every once in a while, you need to be balanced charged. This might be okay to do it every once in a while, or to charge it occasionally using this in a pinch, but you kind of need to balance it. So anyway, we're going to test the red one. We're going to see if it's any different. The wiring is kind of weird on this one. It has these 3 pads over here, and it shows this VH marked one as being the sort of second cell from the first cell from the positive. And then this VM is the other cell over here, as you can see. And then VL is just not connected. I'm not sure what that one's supposed to be for at all. And then the power input is going to go across, well, the power input and the power output is going to be across P plus and P minus. So we're going to go ahead and solder the bridge rectifier slash charging device onto that, and we'll hook this in to the batteries and charge it up, see how this one behaves. Part of the reason why I don't like this particular design is just how close together these 2 solder pads are. I mean, it's not that bad, but if you get a stray wire across that, it is going to short out one of your lithium cells. I mean, these 2 are kind of close together as well. Well, they're all kind of close together, but this one, it at least spaced out your individual cells quite a ways. The output wires are reasonably well spaced. I'd say the output wires are far enough apart on this as well. It's just these two that are kind of close. So anyway, I'm gonna go ahead and plug this in, take some measurements, and see what we end up getting. So we'll bring our old friend, the current limiting resistor, back in. Actually, we want to go over this side. I'm going to limit the current down to about 1 amp again, and let this charge up. It'll take a little while to fully charge, since we drained it down so much the last time. Bring our multimeter in. Some basic checks. We'll make sure about 10 volts there. It shouldn't be too much of a drop between those and these. Yep, that's correct. I don't believe that these actually require heat sinking in order to get the 30 amps, though that would require testing probably. So we'll go ahead and measure the individual cell voltages. First one is 3.57, the second one is 3.63, and the last one is 3.64. So one of them is a little bit lower than the rest. I'll check to make sure we're not shoving too much current into this pack, because I know it doesn't like being charged real fast. These things in theory will be able to handle 30 amps in and 30 amps out, by the way. I do believe that's what they're rated for, so we're pushing 1.22 amps, which is probably just a little bit too much. I'll go ahead and re-zero that since I moved it. I'm gonna lower the current draw just a little bit. About 800 milliamps, that's about what I want to put into this pack. So we'll let this charge up for a while, and I'll get back to you when something happens. Alright, so the charging has terminated on this pack, and I actually did get the multimeter hooked up to it this time, so we're going to go ahead and look in here. Maximum voltage was 12.68 volts, so again, kind of high. These things don't seem to cut off at a precise voltage that you would kind of expect something dealing with lithium to do. And the kind of scarier thing about this, if we look at the individual cell voltages there, we got 4.08, the middle pack 4.22, which was about 4.3 as it was charging, and the last one 4.19. So, and now if you look, our current voltage is at 12.49 volts, so our battery is really not even fully charged. That's probably mostly because we don't have the constant current, constant voltage charging going on here. We just have a voltage detection that's eventually dropping off. So anyhow, next step, we will disconnect the charger, and I'm going to drain the battery at about 1 amp this time, because that's what I ended up doing toward the end of the last test anyway. So we're just going to start with draining about 1 amp from it, so the entire 10 ohm resistor, and we can measure the amount of current getting pulled out of this as well. About 1.4 amps. So anyway, I'm gonna let this sit until it drains down again, and we'll see what happens. Alright, so it has shut off. Let's go ahead and take a look and see what the minimum voltage was. 9.38 volts was the minimum, so that probably cut out at a reasonable voltage, considering that some of these, or the cells, are out of balance quite badly at this point. Let's just check and see how badly out of balance they are. Mind you, these have only been charged and discharged a couple of times without using a balance charger. So let's see how far off they've gotten. 3.52, 3.62, so those are off by 1/10 of a volt. And 3.62 on this one as well. So one of these packs is just a little bit lower than the other ones. Alright, so anyway, these cheap little BMS boards, I'm not too impressed with the things, mostly because they don't have any kind of way to balance charge the cells or do any type of proper charging. Really, all these are is protection boards, which is, to be fair, what this one was advertised as. This one was advertised as a BMS though, and I can't really call something that doesn't have balance charging a BMS, and it doesn't do proper constant current, constant voltage charging that these lithium battery packs require. So by using one of these, you're not going to get the full capacity into these cells, and you're also going to have issues where the cells are not going to be balanced. So overall, these things, at least the ones that I have, are probably not worth it. It's probably better just to get a hobby grade RC charger and use that. But what I'm starting to wonder is if we couldn't make a balancer essentially out of an Arduino for one of these lithium battery packs, and then use something like this as a protection circuit for it. But that may be a project idea for another video. So anyhow, that's my findings with these little BMS boards. I might try to keep searching for one that actually does specifically claim to be able to balance charge one of these battery packs. So anyway, that's about it for now, guys. Bye.